There's a ton of vocabulary. If Algebra 2 has been a while for you, this is reminding you what a polynomial function is. It has to have real coefficients, meaning no imaginary numbers, but irrational numbers are okay. So pi is okay as a coefficient. The square root of 2 is okay as a coefficient. The fraction 3/4. So your coefficients can be any number on the number line, but it has to have a whole number in the exponent. So you can't have a fractional exponent or negative exponent. And it says polynomial functions are smooth and continuous. And that's what a whole number is. Okay, so standard form is exactly what we've been doing for quadratics. You just write it from highest to lowest exponent. The degree is your highest exponent, and the leading coefficient is the coefficient in front of the highest term. Here are a bunch of names. So we kind of already looked at a lot of these parent functions, but a constant function is just like that horizontal line, y equals 7, degree is 0. Linear functions look like this. Quadratic functions look like this. Cubic functions. We've talked about quartic because we learned how to factor them. And then higher than quartic, you just call it 5th degree or 6th degree or 7th degree. So it doesn't have a special name. And then you need to be able to classify a function by its degree. So it could be a cubic. And then how many terms does it have? Is it a monomial, binomial, trinomial? And then if it's just more than 3 terms, you could just call it a cubic polynomial because there's like 4 terms or 5 terms. So I want you to be able to name them. We're going to practice this in a minute, but like this would be a linear binomial or a quadratic trinomial. I only put these non-polynomials on here because of the SAT. I'm not going to be asking you about these in this unit, but on the SAT, if they ask you, what is the degree of 4y cubed? The degree is 3. I'm not going to ask you about y cubes, not a function. And then 3xy cubed, this is not a polynomial, but its degree is 4 because the x has a power of 1 and the y has a power of 3. And so this one right here, they consider having a degree of 5. X squared y cubed has a degree of 5. That's different than up here. So up here, this was considered 4th degree, right? I didn't go and add together this 5x, right? Because this is a polynomial. The rule for a polynomial is just what's the biggest term, x to the 4th. So I hesitate to throw this on there to confuse you, but just in case you see anything funky like this on the SAT, I wanted you to know that that's considered 5th degree. X squared y cubed is considered 5th degree, but those are not polynomials. So those are not going to be on your test on Friday. All right. Here's another term to review, which we've been talking about, but the zeros of a polynomial are the x-intercepts, the solutions, the roots. Those are all synonyms for each other. So solve for all the roots, solve for all the x-intercepts. It means the same thing, the x values that make the polynomial 0. And if a polynomial can be factored, the zeros are the x values that make the factor 0. And a polynomial can have maximum the same number of zeros as its degree. So a quadratic function could have 2 x-intercepts, right? But a quadratic function could have 0 x-intercepts, and a quadratic function could have 1 x-intercept. So this is saying it has the maximum of the number of x-intercepts as its degree. So if it's quadratic, it could have 2, but it could have less. So if it's a 5th degree, it could have 5, but it could have less. So this says, let's factor this and find the zeros and then sketch the graph. This is a quadratic that you should already know how to factor from our review. So what are the factors of -12 that add up to +4? What would you say the factors are? +6, I think, right? +6 and -2 to get +4. So x plus 6, x minus 2. So we know that its zeros are x equals -6 or +2, right? And then this is just a parabola. So we're going to start practicing how the zeros help you sketch the graph of a bigger polynomial, cubic, quartic. So once you have your zeros, you're going to determine their multiplicity. So that's another important term for polynomial functions. So the multiplicity is just the degree of the root. So here's an example of a polynomial, x times x minus 5 squared. So you've got two separate factors, the x and the x minus 5. So the x has a multiplicity of 1 because x to the first power is just showing up once. X minus 5 has a multiplicity of 2 because it's x minus 5 times x minus 5. So it says that 0, right, that's what this 0 would be, and positive 5 are your two x-intercepts. So it says 0 has a multiplicity of 1 and 5 has a multiplicity of 2. So I want to show you how that affects the graph. So let's plot 0 and 5. And I'll just do it on my graphing calculator to save time. But if we plot x times x minus 5 squared on the calculator, I want to show you how one of the x-intercepts is different than the other. So here is, so what's happening? At 0, it's cutting through the x-axis, and then it's going to come up to this turning point, go back down, and then it just touches at 5 and bounces off. So the multiplicity affects what type of x-intercept you have. Does it cut through the x-axis, or does it bounce off? I kind of think of this as like a quadratic. It's bouncing off the x-axis because it is a factor that's kind of like a quadratic. So let's see, this graph looked like something like this. So it cut through at 0 and it bounced off at 5. So you need to be able to factor, to find your x-intercepts, and then identify their multiplicity to sketch the graph. And it says odd multiplicity, the graph will cross the x-axis. So I think of that as cut through. And then even multiplicity, the graph will touch the x-axis without crossing it. So I think of that as bounce off. So if it's just like x, like a linear function, it just cuts through. If it's like a quadratic function, it bounces off. But then third degree would cut through, fourth degree would bounce off, even versus odd. So we're going to practice graphing with that. And then the last thing that we need to kind of add in is the end behavior, which I just hinted at last week. I always think of my quadratics because quadratics, you already know what their end behavior is, right? So if you, I'll do it on here. For the purpose of this video here, so if I have a quadratic, you don't have to write this down, but 2x squared, right? I know that that's concave up. And if I had like y equals negative 2x squared, I already know that that's concave down. So what else do I know about a quadratic? The ends both go up or the ends both go down. Let's think about our friend, the linear function. Y equals negative 3x. Think about what that looks like, right? The ends go in opposite directions and the right end is going down because of that negative leading coefficient. So basically from quadratics and linear functions, you know all of the end behavior rules. We're just applying them to all of the other functions that are polynomials. So you look at the leading coefficient, right? The number that comes first. If the right side is positive, the graph will go up on the right. But if it's negative, the graph will go down. So your leading coefficient, you do this first. Your leading coefficient tells you the right side of the graph. And then the degree of the function, you look at second. The degree of the function is going to tell you what the left side does. If it's even, like x squared, they're going to go in the same direction. If it's odd, like a linear function, they're going to go in opposite directions. So it says if the degree is even, the left side goes in the same direction. And if it's odd, they go opposite, odd, opposite, both start with the letter O. So to me, this, you don't really have to memorize this as a rule. Just think about your friend, the quadratic, or the linear function. All right, and the last little piece that's not quite as important. The number of turning points that a graph has is one less than the degree. And you could think of a couple graphs you know. A quadratic has a degree of 2. How many turning points does it have? 1. A linear function has a degree of 1. How many times does it change direction? 0. A cubic function could look like this, or it could look like this. So it might have 0 turning points. It never changes direction. That's called a point of inflection, not a turning point. Or it could have 2 turning points, right? So cubic has 2 turning points, 1 less. So just sketch some graphs for yourself to figure this rule out. But if this has a degree of 10, it would have 9 maximum turning points. It might not have 9, but it could have 9. And then this has a degree of 3, so it has 2 maximum turning points. Might have 1, might have 0 turning points. So you'd have to look at the graph to figure this out. When you get to calculus, you'll be able to figure out how many turning points it has using the derivative, because a turning point, right, will have a tangent line that has a slope of 0. So you use your derivative in calculus to find the turning points. So right now we're just talking about what a turning point is. All right, so let's work through some practice about these rules together and see what you kind of remember or don't remember. So on number 1, here's what you need to do. Identify first, is it a polynomial function? So you're looking for all real coefficients, all whole exponents. If it is a polynomial, you're going to write it in standard form and identify the degree and the leading coefficient. So let's first find the one function that fails our polynomial test. So there's 3 up here that work, and there's 1 that does not work. So let's find out the first one that does not work. Which one do you think fails the polynomial test? So you're looking for real numbers. Real just means it's found on the number line, could be irrational, and whole exponents. So A, B, C, or D, which one fails the polynomial test? Why does D fail? Right, so this is not a polynomial. So I don't have to do any more work for that function, but the other 3, they pass the polynomial test. Even though pi is an ugly irrational number, it's on the number line. Even though here the square root of 3, this works because the x is outside the radical. If you had had the square root of x, it would have failed the polynomial test. Absolute value would fail the polynomial test. 2 to the x power. If x is in the exponent, it fails the polynomial test. So these all pass. Let's do the first one together. How would I write this in standard form? 2x cubed is the highest power, so that will come first. Then 2x squared is the next highest power, so plus 2x squared. Then x is the next highest, so minus pi x, and then my constant would go last. So that's standard form. Then I have to identify the degree and the leading coefficient. So my degree is what? What's the highest exponent power? 3, x cubed. So my degree is 3. And the leading coefficient, what number is coming first in standard form? It's leading, so it's 2 is the leading coefficient. All right, you do B and C the same way. So write it in standard form, state the degree and the leading coefficient. And actually, go ahead and do example 2 as well. Determine if those are polynomial functions, state the degree, or say why not. So try B, C, and number 2. Algebra 2, or you never fully understood what the heck multiplicity was. Multiplicity is how many times is the factor showing up. So here I have x, and that's only showing up once, and x minus 5 is also only showing up once. So each of these factors has a multiplicity of 1. So it says find each real zero and its multiplicity, determine if the graph will touch or cross the x-axis. So my two x-intercepts are 0 and positive 5, because x would be 0 here and x would be 5 here. And the multiplicity is odd for each of them, right? So it's going to cut through at both. And if we look at what the graph looks like, I'm graphing x times x minus 5. So we're looking for it to cut through the x-axis and then cut through the x-axis. So part B, this time I have a multiplicity of 1, but x minus 3 has a multiplicity of 2. So something different is going to happen at this x-intercept. So my x values are 0 and positive 3, but it's going to cut through at 0 and it's going to bounce off at 3. And so if I show you the difference in what that graph looks like, x times x minus 3 squared. So at 0, we said it's going to cut through, but then at positive 3, see how it does a squiggle and then bounces off? So it changes what the whole graph looks like based on that multiplicity of that x-intercept, which I think is kind of cool. And all of the polynomials follow that same rule. All right, part C. I cannot tell the multiplicity because it's not in factored form. So you need your factoring skills to put this in factored form. So what do I always look for first? Greatest common factor. What is the greatest common factor? What can I pull out of each term? 5x. So I can pull out a 5x, and then when I divide each of these terms by 5x, what do I have left in the parenthesis? So 5x cubed divided by 5x would be what? 5 divided by 5 goes away, but then I'd have x squared minus 4, which is difference of squares. So I can take this one step further. 5x, x plus 2, x minus 2. So now I'm in fully factored form. I need to be here for multiplicity. So the multiplicity of each is just 1, right? So it's going to be a cut through, cut through, cut through. And x can be 0, negative 2, or positive 2, and they're all cut throughs. So what was my function? 5x to the third minus 20x. I'm just going to graph it in standard form to show you that we got the right answer. So I'm cutting through at negative 2, I'm cutting through at 0, and I'm then cutting back through. So this is a big S. Up, cut through, cut through, cut through. Okay, let me see. Find the x-intercept and multiplicity, find the end behavior. So at least if we get through the notes, we can start tomorrow with kind of practicing it, because I didn't assign this for homework tonight. So I think it's okay. Sorry, I'm going to show you something new now. Here we are building a function backwards. So we are taking these 3 x-intercepts, knowing that the degree is 3, and knowing that this graph goes through 2, 36, and we're going to build a function. And so this is what I do when I build a function for your test. I make sure that it actually does have x-intercepts that you can find. So if you know the x-intercepts, you can write out your factors, right? I don't know the stretch factor, but I know that x plus 2 has to be a factor if negative 2 is an x-intercept, right? And I know that x minus 3 has to be a factor if positive 3 is an x-intercept, and then x minus 5, right? Your factors are opposite what your zeros are. So I only have to solve for this a. The a will tell me how steep it is and if it's up or down. I have the point 2, 36 to help with that. So I haven't used this point yet. So I'm going to plug in 2 for all the x's and 36 for the y value and see what a has to be. So if you have an x and a y, you can solve for the final variable there. So 36 equals a, 2 plus 2, 2 minus 3, 2 minus 5. So you solve for a. Multiply your constants together and divide to the other side, and it'll give you what a has to be. And a could come out as a fraction, a whole number, positive, negative. So I'm taking 36 and dividing by positive 12 is what it looks like, right? 36 divided by 12 is 3, so A is 3. Did some people get that? So then if you want to just write your final answer, 3 times x plus 2x minus 3x minus 5. I would not multiply that out. I would leave it in factored form. So I did 4 times -1 times -3. I multiplied those three numbers together. That's positive 12 because two negatives. And then I divided 12 to the other side to get A by itself. I think maybe in Algebra 2 you were exposed to this process but didn't really practice it much. But that's a way that you can take, the big takeaway is that the zeros create the factors, right? And then the reason it told you the degree was 3 is just so you know that there's no multiplicity that's like hiding or something. So that is a degree of 3. X times x times x is x cubed. So it's a way to take a point and solve for a different value. All right, and then here we go. Let's try 5a together and then see if you can do 5b. Find the x-intercepts, figure out their multiplicity, and then sketch the graph using intercepts, multiplicity, and end behavior. So what are my two x-intercepts? 0 and positive 1, right? In factored form, it should be easy now to find your x-intercepts. So let's plot that on the x-axis. So there's my two x-intercepts. And I know that it's going to bounce off at 0, right? Because this is a multiplicity of 2. So it's going to bounce off, and then this has a multiplicity of 1, so it's going to cut through. I need to figure out what the other ends of my graph are doing. So that's why you need to know about end behavior. If I put this in standard form and multiplied everything out, what would my leading coefficient be, my A value? Positive 1. That tells me that the right side of this graph is going to go up, because I just said it was positive. Now I need to think about what's the total degree of this function. So if I multiplied these out, basically you're adding the multiplicities together, right? So this would be a cubic function. X squared times x is x cubed. What's going to happen on the left? It's going to go down because it's going to go the opposite direction of the right-hand side. So once you have what the right side is doing and what the left side is doing, you take into account that it's going to bounce off at 0 and then cut through, and there's your graph. So that's a lot of information assessed in one question. Can you find x-intercepts and determine their multiplicity? Can you figure out the overall degree and leading coefficient? Can you figure out the end behavior? So that's like a 5-step question. It's packed, right, of all this polynomial information. So see if you can try part B the same way. Identify your x-intercepts, end behavior, take a stab at it, right? Because it's hard to figure out when you're first starting out what these bumps are doing here unless you actually try it yourself. So we'll try B and then we'll try 6 together, the end behavior, putting this all together. And because of calculus, this is saying as x approaches infinity, that just says as x goes to the right side of the graph, what do the y values do? The function goes up. So instead of writing up, we just say that the function goes towards positive infinity. That's just rewriting this in mathematical language. The right end of the graph goes up. As x goes to positive infinity, the function goes up towards positive infinity. But to me, the level of difficulty is the same. So I want you to be able to get these types of questions correct because you know the knowledge, but just the notation is tricky. The left end, that's as x goes to negative infinity, the left side of the graph. What's the left side of the graph doing? Well, we said the left side of the graph was going down, so the function is tending towards negative infinity. So we're just using positive and negative infinity as kind of the left and the right side of the x-axis and up and down on the y-axis instead of saying up, down, left, right. Positive and negative infinity are just showing you the directions on your x-axis and y-axis. So see if you can answer 2 and 3 the same way. So I'll give you a minute to try 2 and 3, and then I guess this is where we will stop. So keep out your stuff to check your answers, and then we'll end here today. I think I crammed your brain with enough on this Monday. Your brain's about to explode from a unit of polynomials. This is a great crash course for the SAT, though, I'll tell you. Just reviewed 3 units of Algebra 2 in a week. Did you all try the infinity part down at the bottom as well? Just getting used to that notation. We'll see it again multiple times. So in number 2, we've got a negative leading coefficient. So the right side's going down. So that would be negative infinity down here. And the left side, I look at the degree. The degree is odd again. So odd opposite, so down up. So negative infinity, the opposite of that's positive infinity. And then this is positive 1 as the leading coefficient, so up. X to the 10th is even, so it's like a quadratic. It's going to go the same direction on the left and the right. So up is positive infinity, positive infinity. So that's where we'll stop.